Good day everyone, I am Sir Glenn and for this video I'll show you how to perform the 10 Geogebra Essentials. The first Geogebra Essential is locating the triangle centroid. This is about creating a triangle and finding the intersection of its medians. In doing this, you will make use the following tools: new point, segment between 2 points, midpoint or center, intersect two objects, and move. For you to learn how to perform this GeoGebra Essential, watch this video. For us to perform the first essential, of course, we need to open the GeoGebra software. We do not need this view. This is the algebra view. So what are we going to do? We click this icon here, and then we go to perspectives, and we choose geometry. So to construct the vertices of the triangle ABC, we click the new point. Where can we locate that one? We click the point tools and then click this one. And after choosing that, we click three different locations on the graphics view. So 1, 2, and 3. For us to display the label of the points, we select Show Hide Label button from the list under the Move Graphics View button. So where can we find that? We can find it here in the General Tools. So we can find Show Hide Label. How can we do that? We just click Show Hide Label and we click each object that we wish to hide the label, but we do not want to hide the label. So what are we going to do is to click the three objects to display the name of the objects, the label of the objects. So now we select the segment between 2 points tool to connect the points. Where can we find the segment between 2 points tool? In the line tool. So we click the line tools and then we can see the segment, this part. So we click that, and then for us to connect the points, we just click each point, and then connecting this one to C, and then from C to A to create the sides of our triangle. So next, we determine the midpoints of AB and AC. To get the midpoint of AB, the midpoint is of course the center, this one, the center of each side. To get the midpoint of AB, we select the midpoint or center tool. So where can we find the midpoint or the center tool? We can find it in our point tool. So we click this one and then we locate the midpoint or center. So what are we going to do? We just click point A and click on point B. So we click this one, and here, as you can see, there appears the midpoint. Same process, we click point B and click point C to determine or to locate the midpoint of this side, and same here, point A to point C to locate the midpoint of side AC. So the next step here is for us to connect the vertex to its opposite midpoint. So doing that, we click the line tools and then the segment. We select segment and then we just click each vertex and we click also its opposite midpoint. Same process, we click the vertex B and click its opposite midpoint, click vertex C and click the opposite midpoint, which is D. So after that, it is very evident that the intersection of the three lines inside our triangle is the centroid of our triangle. So how can we identify the exact location of the intersection? We click the point tools and locate intersect, and then all we have to do is to click the center. So that is now the centroid of our triangle. Point G is the centroid of our triangle. So trying to move the vertices, the blue dots, they can be moved because they are independent objects. But if we try to move the gray dots or the black dots, we cannot move them because they are dependent objects. Meaning, they cannot be moved if the objects that they lie within is not being moved. Okay, so that is how we locate the centroid of our triangle. For the second GeoGebra essential, it is about constructing a rectangle. This is about creating a rectangle using the segment tool as well as the parallel and perpendicular line tools. Aside from that is the process on how to measure the length of segments and angles. For you to learn how to perform this essential, watch this video. The first step is to construct segment AB. How are we going to construct segment AB? We proceed in the line tools and locate segment, and then we click two different locations on our graphics view. So this one and this one. This is our segment F. Next, we construct two lines which are both perpendicular to segment F and passing through the two endpoints. So what are we going to do? How are we going to do that? We click the special line tools and we locate perpendicular line. So the first step is click the segment and then click the first endpoint, which is A. So repeat the process. We click the segment and we click the second endpoint, which is B, to construct two perpendicular lines which are perpendicular to segment F. So if we try to move this partial object that we created, we can see that we can freely move it because the blue dots indicate independent objects. The next step is to create a point that lies on line G. To do that, we proceed in clicking this icon here and then we locate point and we click to any location here in our line G. That is our point C. Observing the shade of point C, it is a bit lighter as compared to points A and B. If we try to move this point, as you can see, it is very evident that we can only move it along the line G. So this is a semi-free object or semi-independent object. We can move it along the line where it lies. The next step here is for us to create a line parallel to segment AB. To do that, we click the special line tools and we locate parallel line. All we have to do is to click the line, the segment AB, and then we click point C. So this is how we create a line which is parallel to segment AB. So for us to create point D is the intersection of line H and line I. To do that, we click special line tools and we locate perpendicular. We click the intersection of line H and line I. So that is point D. As you can see, it is gray colored. If we try to move that, we cannot move it because it is a dependent object. So as you can see, we already have the endpoints of our rectangle. The next step here is to hide this by right-clicking each line and clicking show object to hide the object. So same here and same here. So for us to construct the sides of our triangle, we click line tools and we choose segment. So connect A and C, connect C and D, and connect D and B. And after that, we hide the labels of each segment. So that is how we construct a rectangle in GeoGebra. The third GeoGebra essential is about triangles, incircles, and circumcircles. This will show you that in any triangle, a circle can be created that passes through its three vertices. You will learn that you can always create an inscribed circle. The circle that passes through the three vertices of a triangle is called the circumcircle of the triangle, while the circle that inscribed in it is called its incircle. For you to learn how to perform this essential, watch this video. For us to perform the third essential, of course, we need to open Geogebra and make sure that the geometric view is displayed. So label the new points only. How do we do that? We click this icon here and it will show this one. We click the settings icon, and then for labeling, we choose new points only. Like that. So the next step is we select the polygon tool. So this one is the polygon tool, and we can locate polygon, and we click on three different locations on the graphics view. So for A, B, and C, and uh, return to A to finish constructing triangle ABC. To construct the perpendicular bisector of AB, we select the perpendicular bisector. So where can we locate that? It is on the special line tools. There is the perpendicular bisector. We locate this, we click it, and then to construct the perpendicular bisector of AB, we click A and B. So same process to create the perpendicular bisector for segment BC. We click B and C, and for AC, for segment AC, we click A and C. So as you can see, we have the intersection of the three perpendicular bisectors for us to identify or to locate the exact point of intersection. We click the point tools and we locate intersect, and we click this one, the center. So D is the intersection of the perpendicular bisectors. So point D now will be the center of the circle passing through the three vertices of the triangle. So to construct the circumcircle, we select the circle with center through points. So where can we locate that? We choose circle and arcs tools, and we choose circle with center through point. So we click that and we click D and A. So if we try to move the blue dots, as you can see, it is movable, and the shape of the triangle changes, but it still remains inside the circle. So the next step here is for us to remove or to hide the perpendicular bisectors. To do that, we right click each line and we click show object to hide the objects. Same here and same here. So now, since the perpendicular bisectors are already hidden, the next step is for us to construct the inscribed circle. To construct the angle bisector of angle A, we select the angle bisector tool. So where can we locate that? We can locate that in our special line tool. So we click that and we can locate angle bisector here. So after clicking or after selecting angle bisector, we click on point B, point A, and point C to construct the angle bisector for angle A. Same process, to construct the angle bisector for angle B, we click A, followed by B, and then C. Same process for angle bisector, the angle bisector for angle C, we click A, we click C, and we click B. So as you can see, just like in the perpendicular bisectors, we can see that there is the point of intersection for the angle bisectors. So for us to locate the point of intersection, we click the point tools and locate intersect, and we click their intersection. So as you can see, the point of intersection for the angle bisectors is point E. After that, we hide the angle bisectors. So we click and then we click show object to hide the object. same here, and then same here. Point E now is the center of the inscribed circle. We now construct a line perpendicular to AB and passing through E. To do this, we select the perpendicular line tool. So where can we locate that? Here. And we locate perpendicular line. And then we click point E, and we click segment AB to create a line perpendicular to segment AB. Using the intersect tool, intersect segment AB and the line perpendicular to it. So in the point tool, we locate intersect and we click the point of intersection for the perpendicular line and segment AB. To construct the inscribed circle, we select the circle with center through point. We click point E and then we click point F. So we already created the inscribed circle or the circle inside the triangle. So the next step here, we hide this line. So that is how we create circumcircle and inscribed circle. If we try to move this dot B, we can see that the triangle and the inscribed circle remained inside the circle. The fourth GeoGebra essential is about angles, lengths, and object properties. This will allow you to use GeoGebra to investigate if a relationship exists between the interior angles of a triangle and the lengths of its sides. You are going to learn two new tools, the angle and the distance or length tool. For you to learn how to perform this essential, watch this video. For us to do the fourth GeoGebra essential, we need to open the GeoGebra first and then make sure that the geometric view is displayed. And we need to set the labeling into new points only. So how are we going to do that? We click this one, and then here, and then this icon again, and then make sure that it is set to new points only. So the next step here is to construct segment AB by selecting the segment between 2 points tool and then clicking two different locations on the graphics view. So we can find the segment between 2 points here in the line tools. The second one, we locate segment. Then for segment AB, and then for BC, we just click point B and then click any location here. And then next one is click point A to point C to close our triangle. We now determine the length of the sides of the triangle. So to do this, we select the distance or length tool. Where can we locate that? It's here in our measurement tools. So in the drop down options we have here, we can see distance or length. How are we going to use this? We just click the segment to display the distance or the length of the segment. So for segment AB, if I click this one, it will show 6.1 as the measurement. If I click this segment for the segment BC, it will display 9.73. And for segment AC, if I click this, the distance displayed will be 8.4. So that is how we measure the distance or the length of a segment. So now, we select the move tool and try to drag the vertices of the triangle. So if we try to move the vertices, the distance will automatically change. So as you can see, it is very evident. So the next step here, we measure the angles of the vertices by constructing angles using the angle tool. So where can we locate the angle tool? We can locate it in our measurement tools. So if we click this one, we can see the first option is angle. So we click that, and for us to display the measure of the angle, for example, the angle that we wish to measure is angle A, we click B followed by A and then followed by C. So the measure of angle A is 92.41. For the angle C, we click A followed by C and then for B. So the process here, it should be in clockwise direction so that the measure of the angle which will be displayed is the interior angle. Because when we try to, or when we do it in a reverse manner, for example, if I want to measure the angle for this side, angle B, and I did it in counterclockwise direction, for example, this one, I'll be clicking point A followed by B and followed by C. It shows the measure of the exterior angle. So to avoid that, if we want to measure the interior angles, make sure that we do it in clockwise direction. Another way to avoid this, if sometimes we try to measure a specific interior angle and then the measure that is being displayed is the measure of the exterior angle, all we need to do is to choose the move tool and then we right click the angle and choose settings, and here in under the basic tab, we can see angle between. So just set this to 0 degree to 180 degrees to fix it. Same as through here, just set it to 0 to 180, and for the last angle, set this to 0 degree to 180 so that when we try to move the vertices, the angles which will be measured are all interior angles. Aside from that, we can change the color of the angles. So how are we going to do that? We right click, okay, right click, and then we choose settings. And then under the color tab, we can find different colors where we can choose the color that we want for the angle. So I'll be choosing this color for angle A. So for angle B, I'll just click it and then choose a color. And for the last angle, I'll choose this color. So we can customize everything under the properties window. So if you want to thicken the sides, so you just click this one. And then under style, we can see line thickness. So I'll just set it to 7. For segment AC, I'll set it to 7 as well. And then for segment BC, I'll set it to 7 as well. So we can find these things in the properties window. So you can customize the objects that you've created or you've placed in the geometric view. So if we try to move the vertices, as you can see, the measure of the segments automatically change, as well as the measure of the angles. So this is how we measure the segments and the angles, specifically the interior angles of a triangle, using GeoGebra. The fifth essential is about the compass tool and the SSS congruence. This is about how to mimic compass and straight edge construction using GeoGebra's compass and segment between 2 points and ray through 2 points tool. You will use the concept of the SSS congruence, that is, you will show that if the three corresponding sides of a triangle are congruent, then the triangles are also congruent. For you to learn how to perform this GeoGebra essential, watch this video. For us to do the fifth GeoGebra essential, make sure that the geometric view is displayed and then the labeling is set to new points. So the labeling here, it is set to new points. So the first step here, we construct triangle ABC by using the polygon tool. So click this one and select polygon, and then click 3 different locations in our graphics view, graphics display, and we go back to A to close the polygon. Our next task is to construct a triangle congruent to triangle ABC. So we use the concept of congruence, SSS congruence in particular. We copy the length of the sides of the triangle and produce another triangle. So how are we going to do that? So first, we need to copy BC, but before we do that, we first construct where we will place the side congruent to BC. So to construct ray DE, we select the ray through 2 points tool, then click two different locations on the graphics view. So where can we locate the ray through 2 points tool? It is found in the line tools. So clicking this icon, we can see that it contains the ray tool. So we click that and then we click to two different locations in the graphics view. So next process, we use the compass tool to measure the side lengths of BC. And then we will be using ray DE to construct a segment congruent to it. So we can locate the compass tool under the circle and arcs tool. So by clicking this one, we can see that it contains the compass tool. So we click that and we click to the segment that we wish to copy its length. So I want to copy the length of side BC. I'll click this and a circle appeared. So by using compass, it copies the length of the side through its radius. So as you can see, so if I move the circle and I'll put it here, C becomes the center, and then the measure of side BC becomes the radius. So if I move this and I'll place it here, D becomes the center of the circle, and then the radius is this point up to here. So the next step here, we try to locate the point of intersection of the circle and the ray. So how are we going to do that? We click the point tool and we locate intersect, and then we click this one to locate the point of intersection of the circle and the ray. So we already have the radius of this circle, which has the same length as to the side BC of our triangle. So the next step here, we now hide this circle. So by right clicking it, we right click and then we click show object to hide the circle. So for us to copy the length of side AB and side AC, we do the same process. So click compass and then we click this side. So it copied the length of side AB through its radius. So we click this one. And then, as you can see, we do not have yet the point here. We proceed in the same process. We click compass and then we click the side that we wish to copy the length. So side AB, we click that and then we click here. So F becomes the center. Afterwards, as you can see, we can see that there is a point of intersection of the two circles. So that becomes the third side of the triangle that we wish to create. So for us to locate the point of intersection of the two circles, we click the point tools and then we locate intersect and then we click this one to obtain the point of intersection, which is G. Since we already have the point G, we now hide these circles. And afterwards, after hiding the two circles, we can now connect the three dots, point D, point G, and point F by using the polygon tool. So D, we connect D to F, we connect F to G, and we connect G to D to close the polygon. So if we try to move the vertex B, as you can see, the second triangle also moves. This is how we use the compass tool and the SSS congruence using Geogebra. For the sixth Geogebra Essential, it is all about sliders and rhombuses. This is about constructing a rhombus using two sliders, the angle slider and the number slider. A slider is a dynamic graphical representation of a number. For you to learn how to perform this Geogebra Essential, watch this video. To do the sixth Geogebra Essential, make sure that the geometric view is displayed and make sure that the labeling is still set to new points only. So the first step here, we construct the first slider, which is the slider S for the side length of the rhombus. So where can we locate the slider? We have here the transformation tools. We click slider and we click any location in our graphics view. So I'll be clicking it on the left side. So clicking it, it will show us the slider dialog box. So it is the number. We choose number and we change the name to S. And then we change or we write the increment to 0.1. We set increment to 0.1 and we click OK. So after that, we create segment EB with length S. So to do that, we select segment with fixed length tool. So where can we find that tool? It is under the line tool. So we click this icon and then we have here segment with given length. So I'll be clicking this one. Let's click anywhere here. I'll be clicking here on the middle part. So for the length, we type S. So and click OK. So as you can see, if I try to move this slider, there is an effect on the segment that I've created. So the next one, the next step, we construct angle slider T. So same process, we click the transformation tools icon and then we locate slider and we click here. I'll be clicking just below the length slider of the rhombus. So I'll click here. So here for the angle, let's choose angle and the name will be T. And then for the maximum, we set it to 180. Make sure that you do not delete the degree symbol and then we leave the increment as is. And then after that, we click OK. So next, we construct angle BAB prime, which will be an interior angle of the rhombus. So we select the angle with given size tool. So where can we locate that tool? Of course, in the measurement tool. So we click this one. So we can see that there is an angle with given size. So you click that and I'll be clicking B followed by A. So a dialog box for angle with given size will appear. So I'll type T because the letter that we use for the angle slider is T. And we leave counterclockwise. We do not change it. And then we click OK. So after that, we connect B prime and A using the segment tool. So we click this one and then we click B prime, the point B prime and point A. So if we try to move the sliders, it will take effect already in our angle. So this is the purpose of the slider to show the changes in the angle and in the length of our angle B prime A B. Now using the parallel line, since our goal here is to create a rhombus, so this is not yet a rhombus, it is just an angle. So using the parallel line tool, we construct a line parallel to AB and passing through B prime. Also, we construct a line parallel to AB prime and passing through B. So where can we find the parallel line tool? In our special lines tool. So we click that and we can see parallel lines. So we click that. We click the segment that we want to create a parallel line with. So I'll be clicking this one. It is, and click B prime. Same here. A parallel line which is parallel to a B prime. I'll click this one and I'll click this endpoint which is B. So as you can see, there exists already a point of two intersecting lines here. So for me to uh, identify their point of intersection, I'll select point tools and locate intersect. I'll click that and I'll click here. So there you have it. We have the point of intersection, which is point C. Afterwards, we now hide these lines. So I'll click show object to hide. For this one, I'll click show object to hide as well. So the next step here, we connect B prime and C to B using the segment tool. So I'll click the line tools and then we locate segment. So we click that and then just click B prime, connect it to C. Same process, just click C, connect it to B. So if you try to move our slider, the rhombus will also move. So this is how we perform the sixth Geogebra Essential, which is about sliders and rhombuses. For the seventh essential, it is about using the keyboard commands. This is about constructing mathematical objects using keyboard commands. You will learn how to construct an equilateral triangle by mimicking compass and straight edge construction. For you to learn how to perform this GeoGebra essential, watch this video. To perform the seventh GeoGebra essential, we open GeoGebra and we select Algebra and Graphics in the Perspective panel to open the Algebra and Graphics window. So we need the Algebra and the Graphics window. We do not need this geometric window. So for us to change it, we click this one and we locate perspectives and we click graphing. So this is the algebra view and this is the graphics view. Okay, so to perform keyboard commands, we try to plot A with coordinates 1, 1. So we type A, capital letter A is equal to 1. The coordinates are 1 and 1. So for the second coordinates, point B is equal to, it has coordinates 5 and 1. So everything is being done using keyboard commands. So next one, we construct segment AB. So we type segment A, comma, B. So as you can see, it automatically connects point A and point B, thus creating segment AB. So after that, we construct we construct a circle with center A and passing through B. So we type circle and A and B. Next one, we construct another circle now with center B passing through A. So we type circle and instead of A, we begin it with B followed by A. So as you can see, the circles are not, the labels of the circles are not shown. So we right click each circle and we show the label. After that, we try to identify or to locate the point of intersection of the two circles. So to do that, we type intersect and parenthesis C, which is the label or the name of the first circle, and followed by D, which is the label of the second circle. And we click enter. Next step, we try to create polygon ABC. How are we going to do that? We type polygon, and we write A, B, and C. So we type A, followed by B, and followed by C. So as you can see, it automatically creates polygon A, B, and C. Since we already have polygon A, B, C, we can now hide the two circles. So we click show object to hide it. We click show object to hide it. We right click point B, we click show object to hide it. So as you can see, although there are things that we can do using keyboard commands, we cannot do everything using them. We always need the help of the mouse to perform other commands. So this is how we use keyboard commands using GeoGebra. The eighth GeoGebra essential is about graphs and their properties. This is about the basics in graphing and how to use GeoGebra command to get the critical points of a function. You will also learn how to graph trigonometric, exponential, and logarithmic functions. For you to learn how to perform this essential, watch this video. To perform the eighth GeoGebra essential, we need to see algebra and graphics in the perspective panel located at the sidebar. So as you can see, the algebra window and then the graphic window are already displayed. But if it's not yet displayed, all you have to do is to click this button, and then you can see perspectives, and just click graphing so that the algebra window and graphics window will be shown just like this. So the first step is we try to graph the function f of x is equal to x cubed minus 3x minus 1. So to do this, we type, so we click this one. So f of x is equal to, we have x and then the symbol 3 minus 3x minus 1, and then we press enter. So this is the graph for the function that we have encoded. So as you can see, it is labeled f. It's not that visible, but the label is right here. It's letter f. To get the roots of the function, we type root and then square bracket f. So the roots are there. As you can see, we have three roots, negative 1.53 and 0. I mean negative 1.53, negative 0.35, and 1.88. So next to get is the minimum and maximum of the graph. So we type extremum, and then square brackets, and we just input f. So the minimum and maximum values here are negative 1 and 1, and 1 and negative 3. So to get the inflection point of the graph, we type inflection point and then square bracket f. So inflection point, square brackets f. So the inflection point is 0 and negative f. So what if we are to get the derivative? So all we have to do is to type derivative, square bracket, and f. As you can see, very evident that our derivative is this one, the graph in red. And as you can see, the label is f prime, meaning when we try to get the derivative of a specific function, when we try to obtain the derivative of a specific function, automatically this symbol will be displayed. So as you can see, the given function is a cubic function. Of course, when we obtain its derivative, the derivative will become, the derivative that we're going to obtain is a quadratic function. That is why the graph is a parabolic graph. Now, we construct a line tangent to a point on the graph. To construct the point, select the new point tool and click the graph of the function f. So we click the point tool and then locate point, and then we click the graph of the function F. So I'll just click here. And then to construct a line tangent to F and passing through G, click the tangents tool, click point G, and click the graph of F. So where can we locate the tangents tool? It's in this special line tools. So if we click this special line tools, we can locate tangents. So we click point G and click the graph of F. So if we try to move the point G, we can see that the roots, the minimum and the maximum point, and the inflection point, those things are the points of tangency. And that is how we perform the eighth GeoGebra essential when it comes to graphing and its properties. For the ninth essential, it is about the text and variables. This is about how to use the text tool of GeoGebra. You will learn about constants and variables, and we will learn how to concatenate them in GeoGebra text codes. For you to learn how to perform this essential, watch this video. To perform the ninth GeoGebra essential, we need to open GeoGebra and make sure that the algebra window and the graphics window are displayed. And after that, we follow steps 1 to 8 in the GeoGebra tutorial number 4. So the first step in that tutorial is we select the slider tool and click on the graphics view to display the slider dialog box. So here in this button, we click this one and then we can locate. You can see that it contains the slider button, and then we click anywhere in the graphics window and then this will appear. So we write in the name letter M, and then the minimum is -10, the maximum is 10, and the increment is 0.1, and we click OK. So to graph the function y is equal to mx, we type y is equal to mx in the input box. So this is the input box. We type y is equal to mx, and then we press enter. If I move the slider to the left and to the right, it is very evident that the line y is equal to mx also changes. Then we create another slider and we name it b. So I'll input b here, and then the minimum value is -10, the maximum value is +10, and the increment also is 0.1. Then click OK. Change this function y is equal to mx and make it y is equal to mx plus b. So I'll just add plus b and then I'll press enter. So if I move this slider, both of the sliders, there is an effect, there is a change on the appearance, the direction of the graph. So this is basically the slope-intercept form of a linear equation. M represents the slope and B represents the y-intercept. So how can we use text and variables in this video? To place the first line, we select the text tool and click on the vacant part of the graphics view to display the text tool dialog box. So where can we locate the text tool? So it's in here in this button. It's here on this button. So by clicking it, we can see that there is ABC text. We click that and then we click anywhere in our graphics view. So I'll click it here. So text dialog box will appear. All we have to do is to input the equation of the line is so in this part we can see the preview, and then this button, if we click it, it's very evident that we have the elements that we've placed. We have F, we have B, and we have M. So we click this and we click F because F is the equation of the line. And then we click OK. So as you can see, if we move the slider, aside from the graph automatically changes, the equation of the line in the text also changes. To display the second line, we type the slope of the line is, and then we select M from the objects drop down. So we click again this button and then locate ABC text. We click anywhere in our graphics view, and then the text dialog box will appear. So we encode the slope of the line is, and we click M, and the y-intercept, we type y-intercept is, and we click B, since I mentioned earlier that M is the slope and the y-intercept is B, and then I'll be clicking OK. So I'll just move it here. So if I move the sliders, aside from the graph changes, the equation of the line and the y-intercept and the slope also changes. So this is how we perform the ninth GeoGebra essential. For the last essential, it is about exporting your document. This is about how to export GeoGebra worksheets to static graphics format. This way, you would be able to use the diagrams in different documents such as articles, blogs, exams, problem sets, and other articles. For you to learn how to perform this GeoGebra essential, watch this video. To perform the GeoGebra essential number 10, I'll just use this output. It says there, we need to open the GeoGebra file that you want to export. So I'll be using this one, and then adjust the position of the drawing and resize the GeoGebra window as you want it to appear when it is exported. So I'll be adjusting the window. So I'll adjust this here, and then the wordings, I'll be placing them here. So after adjusting the window, after adjusting, we now move on to the exporting process. So click this icon here and choose download as, and then you choose which format you want your output to be downloaded. So I'll be choosing PNG image. So I'll check this, and then this will be the title, and I'll click export. Place your picture in a document, open it with a graphics software, and then copy and paste it to your document. So if I'll be showing you the image of the downloaded output, it looks like this. So that is how we export GeoGebra worksheets in our GeoGebra software. That's it for today. Thank you for watching.